Hello friends, welcome to my channel Botanical Studies. In this video, we will discuss about isomerism and types of isomerism. First, let us discuss about what is isomerism. Isomerism is the phenomena in which the compounds which have the same chemical formula but different chemical structures. Isomers are the chemical compounds that have identical chemical formula but differ in chemical properties and the arrangement of atom in the molecule. Therefore, the compounds that exhibit isomerism are known as isomers. The word isomer is derived from the Greek word isos and meros, which means equal parts. This term was coined by the Swedish chemist Jacob Berzelius in the year 1830. Let us discuss now the types of isomerism. There are two primary types of isomerism: structural isomerism and stereoisomerism, which can be further categorized into different subtypes. The structural isomerism is categorized into chain isomerism, positional isomerism, functional isomerism, metamerism, tetoomerism, and ring chain isomerism, while the stereoisomerism is further classified into geometric stereoisomerism and optical stereoisomerism. Let us discuss first the structural isomerism. Structural isomerism is commonly referred to as constitutional isomerism. They have same chemical formula but the chemical structure is different. That is, the functional groups and the atoms in the molecule of these isomers are linked in a different ways. The first type of structural isomerism is the chain isomerism. Chain isomerism, it is also known as skeletal isomerism. The component of these isomers display differently with respect to branching of carbon. For example, pentane, isopentane and neopentane, they are the chain isomers with same chemical formula C5H12, but structurally they are different. Pentane with 5 carbon atom in a straight chain, isopentane with 4 carbon atom in a straight chain, and neopentane with 3 carbon atom in a straight chain. Second, positional isomerism. These isomerism have same chemical formula but the position of the functional groups or substituent atoms are different. Typically, these isomerism involves the attachment of functional groups to different carbon atoms in the carbon chain. For example, the chloropropane having the chemical formula C3H7Cl shows two positional isomers. In one chloropropane, chlorine is attached to the first carbon atom, while in 2-chloropropane, chlorine is attached to the second carbon atom. That is, the position of functional group of chlorine is different, but chemical formula is same. Functional isomerism. It is also known as functional group isomerism. As the name suggests, it refers to the compound that have the same chemical formula but different functional group attached to them. For example, the compound with same chemical formula C3H6O shows two functional isomers, that is propanol with aldehyde as a functional group and propanone with ketone as a functional group attached to them. Fourth structural isomerism is the metamerism. This type of isomerism arises due to presence of different alkyl chains on the each side of functional group. It is the rare type of isomerism and is generally limited to the molecule that contain a divalent atom such as sulfur or oxygen surrounded by alkyl groups. For example, the compound with same chemical formula C4H10O can be represented as two metamers, ethoxyethane and methoxypropane. Fifth structural isomerism is the tetoomerism. A tetomer of a compound refers to the isomer of the compound which only differs in the position of protons and electrons. Typically, the tetomers of a compound exist together in equilibrium and easily interchange. It occurs via an intramolecular proton transfer. For example, ketoenol tautomerism. Ring chain isomerism. In ring chain isomerism, one of the isomer has an open chain structure whereas the other has a ring structure. They generally contain a different number of pi bonds. For example, the compound with same chemical formula C3H6 shows two ring chain isomers, that is propane with open chain structure and cyclopropane with ring structure. Stereoisomerism. This type of isomerism arises in a compounds having the same chemical formula but different orientation of the atoms belonging to the molecules in three-dimensional space. The compound that exhibits stereoisomerism are often referred to as stereoisomers. This phenomenon can be further categorized into two subtypes: geometric isomerism and optical isomerism. First, geometric isomerism. It is popularly known as cis-trans isomerism. These isomers have different spatial arrangements of atoms in three-dimensional space. For example, the geometric isomerism observed in the acyclic but2-ene molecule with same chemical formula C4H8. In cis but2-ene molecule, two methyl groups are present towards the same side of the double bond, while in trans but2-ene molecule, two methyl groups are diagonally arranged to each other. Second stereoisomerism is the optical isomerism. The compound that exhibit optical isomerism shows similar bonds but different spatial arrangements of atoms forming non-superimposable mirror images. These optical isomers are also known as enantiomers. Enantiomers differ from each other in their optical activities. Dextroenantiomers rotate the plane of polarized light to the right, whereas Leo enantiomer rotates the plane of polarized light to the left. For example, the lactic acid is an optically active compound. It shows two optical isomers. One is dextrorotatory and another is leo-rotatory. They forming non-superimposable mirror images. So this is all about isomerism and types of isomerism.